Hello and welcome to Kashmatics. In this tutorial I'll be going over set notation on Venn diagrams and also how to identify regions. I'll be doing lots of examples and hopefully by the end of it you'll improve your understanding of Venn diagrams. So grab yourselves a pen and some paper and let's get on with it. Now I'm fairly sure you'll have seen a Venn diagram before, so I'm not going to bore you too much with the details, but basically what it is, it's a graphical way of representing what categories or properties two groups have. Okay, they might fall into one, they might fall into the other, they might fall into both, or they might fall into neither. And we have certain notation which helps us to identify which regions they fall into, and that's what I'm going to go through next. So make a note of all the notation and what it actually means, because it's going to be important for when we do our examples. Now in my examples the groups are A and B, but it could be anything. It could be French and German, it could be rugby and football, it could be maths and science, it could be netball and swimming. So just bear that in mind. So first of all, if I have a single letter like A, that means the region which lies within circle A, or the people which like category A or whatever it might be. And you show that by shading it in. If it was B, it'd be the other circle instead, so it has to lie within circle B. Now if you see an A with an apostrophe, it means the complement of A, or not A, and that would be the region which lies outside of circle A, and that would be that region there. And similarly, B with an apostrophe is the region outside of circle B. Now there are two other symbols which we need to understand, and the first of those is called the union. Okay, the union looks like a U, okay, and that means or. But the way to think about it is it unites both regions, okay? So it's a union of both regions. The intersection, it looks more like an N, that means and that's where the regions overlap or intersect. So let me just show you what I mean. So if that's region A and that's region B. Now the union is all of that, okay? Everything you see which is shaded. The intersection is where the two circles overlap, and hopefully you can see that with a slightly different shading. So look out for the bits which overlap for the intersection. Now before I continue with the examples, I just want to show you how to identify some of the regions. So if I've got two blue regions, when they overlap, you get a slightly different shade of blue. And I've also used yellow, right? And yellow and blue make green. So if you see green, that means it's an overlapping region. Okay, if you just see blue, that hasn't got an overlap. If you just see yellow, that's not an overlap. But if you see green, that's an overlap. Now if both regions are yellow, then the overlapping part is this brighter yellow color you see around the outside. Okay, so where the yellow is a little bit darker, that's the bit which is just a single region. It hasn't got an overlap. Okay, and the brighter yellow is where the region overlaps. Now I will be going through that again once I do the examples, but I thought I'd just tell you before I begin. So before I go through any of these examples, if you want to pause the video and give it a go, just by sketching it out and shading in the right region, then please do so. Otherwise, just keep listening and I'll go through it. So in this first one here, I've got the union of A and B. Okay, so the union of A and B, that is where A and B come together. So let's shade in region A, and that's that region there. Let's shade in region B. That's that one there. And the union is all of that, okay? It unites as one region, okay? And that would be that region there. This second example has an A with an apostrophe, and that means the complement of A, or everything that is not in region A. So everything that's not in region A is just that part there. So that should have been fairly straightforward. This one here is the intersection of everything that's not in A and in B. Okay, so what you need to do here is you need to shade everything that's not in A, and then shade everything that's in B, and then wherever the overlap is, that's the region you're interested in. So let's do the first bit. So that is everything that's not in A, so everything outside of circle A. This is everything that's in circle B, and remember I've got blue regions and yellow regions, where the blue and yellow cross, where they intersect. Okay, remember this means intersection, that turns green. So I'm only interested in the green part of that, which is this part here. Now let's have a look at this example. It looks very similar to the last one. Okay, this is everything that's not in A or the union of everything that's in B. So what I need to do is shade everything that's not in A and then shade everything that's in B and then unite it all together. So let's have a look here. So this is everything that's not in A. This is everything that's in B. So what I need to do here, because it's or it's a union, I need to shade everything you see shaded there. And what you end up with is that region there. Okay, this next example is the union again. So what I'm going to do is I'm going to identify these two regions and shade it all in. All right, so this is everything that's not in A. So that's all of that. And the other one's everything that's not in B. And that's all of that. And what I need to do is shade all of that in. And I end up with that. Okay, this one's going to be similar again, but this one says everything that's not in A and not in B. Okay, so it's only the bits which overlap that we're interested in. So this is everything that's not in A, so all that yellow region there. This is everything that's not in B, and that's that yellow region there. And the overlap is going to be the brighter yellow color. Okay, so it's this bit around the outside, so none of what's in the circles. And that's that region there. And this is the last example, and here we've got brackets, and these trip people up sometimes. So what you need to do in this case is you need to identify the region that's in the brackets first, okay, and that says A or B. Now we've done that one before. And then the apostrophe on the outside means not everything that's inside the brackets. Okay, so you identify the regions that's inside the brackets and then you do the complete opposite of all that. So let's see what's inside the brackets. So A or B, so that's A and that's B. And without the brackets, what I would have done is I'd have shaded all of that in. Okay, but because I'm doing the opposite of all that, it says it doesn't want that. That's what this apostrophe means. I need to shade the exact opposite of all of that, which is that orange region there. So hopefully that's helped you to understand how to identify regions. Now I've got some questions for you which are the complete opposite of that. So I'm going to give you the regions shaded in already, and you've got to work out the notation to describe that region. Now here's 6 regions for you, but on the right I've got more than 6 regions identified in terms of their notation. Okay, so one of them's not going to fit. So what you've got to do is you've got to work out which one's which. So pause the video, make a sketch of all those Venn diagrams, and there's 2 ways you could go about doing this. You could either shade the regions according to these and then see which ones match, or you could do it the other way around. It's entirely up to you. If I was doing it, I'd probably just shade each of these and see which of those diagrams match, but like I said, it's entirely up to you. So pause the video, give it a go, and then you can check in with the answers shortly. So I'm just about to reveal the answers in 3, 2, 1, and there you go. Okay, so those are the answers there. Right, so I hope that's helped you understand how to use set notation and how to identify regions on a Venn diagram. And in the next video, what we'll be doing is looking at some probability questions based on Venn diagrams. So I hope to see you for that one there, and goodbye for now.